Today we are reviewing the laws of exponents. So we'll just kind of go through what the laws are and then we'll go down and we'll practice some of them. So first of all, when you have the same base and you're multiplying the bases, the exponents get added. So you keep the base, don't change the base, and just add the exponents. When you have a power raised to another power, then this is where we keep the base and we multiply the powers. And then whenever you are dividing with exponents, the way I like to think about it is you kind of have these two cases. And really what I do is wherever the exponent is largest, that's where the variable is going to end up. So like if x is larger than y, then you're going to move your y's up by subtracting them. Or if y is larger than x, then you're going to move the a's down to the y by subtracting them. But remember, every time something goes across the division sign, it subtracts or it changes sign. Okay, so again, I said it changes sign. So again, when you see that there's a negative exponent, that what I like to think about that is that it's on the wrong side of the fraction bar. So if you have a negative exponent, it means it needs to go to the other side of your fraction bar, and then when it moves down, it changes sign. Okay, so this a to the negative 1 would become 1 over a to the 1. All right, and anything to the 0 is 1 unless a is 0. But we don't often have 0 to the 0 because that's technically undefined. But if it's 5 to the 0 is 1, a million to the 0 is 1, x to the 0 is 1, anything raised to the 0 power is 1. Okay, so answers should only have positive exponents, and so you combine all your similar bases. Now, one thing, we're not going to focus on like binomials very much, but there's a really big difference between a product raised to a power and a sum or difference raised to a power. Remember, when you have a product raised to a power, we kind of distribute that power, right? Everything that's multiplied inside gets the power, but that's not what happens when we add or subtract. Whenever we add or subtract and we raise to a power, then that's when we have to FOIL. So we would just write the binomial twice and we would FOIL it together and we would get that expanded, that trinomial. Okay, now let's look at some examples. Okay, so whenever I am multiplying, your coefficients do exactly what the operation calls for, right? So I'm going to just multiply the 3 times the 8, the negative 8, and I get negative 24. And then I am multiplying the bases. So the x is the base, and then I'm just going to add the exponents. So 4 plus 3, so negative 24x to the 7th would be the answer there, simplified. Okay, now we look and we say, okay, again, we're going to start with coefficient to coefficient. So 2 times 2 is, we'll just write that out, 2 times 2. And then I have my x, and this x is to the third, but I have an x to the negative 1 over here. So for now, I'm just going to go ahead and combine them. So if we normally say when we're multiplying, we would add the exponents, but adding a negative would just be subtraction. So at this stage, you can just kind of combine them. And then I would have the y, and then I'd have negative 3 plus 3. Okay, so then 2 times 2 is 4, and we have x squared, and then this would give me y to the 0, right? But if we know y to the 0 is just 1, so we would have 4x squared. Okay, now this is that situation when I have a power raised to a power. So when we have exponents on the inside raised to a power on the outside, this is when we multiply the powers. So I have x to the third times 2 and y squared times 2. So we'd have x to the 6th, y to the 4th. All right, now dividing. So again, when I look at my coefficients, I usually just say, okay, can these reduce? And I usually start there. And I say, okay, 28 and 7, do they have a common factor? They do. They can both be reduced by 7. So the 28, if I reduced it by 7, would be 4. and then this 7 would turn into a 1. So I could say I have 4 over negative 1. Okay, now here's where I decide where my variables go. So they always go wherever the exponent is largest. So see my m on the top and m to the third on the bottom. So that means the m's are going to end up in the denominator, and I'm going to take the m's that are down there, and then this m that got moved down, it had an exponent of 1, and when it comes on the other side of the fraction bar, it's going to subtract. And then I have p's to the 7th on top and p on the bottom. So the p's are larger in the top. So I'm going to have p's on the top, and I have the 7 that are there. And then again, if there's no exponent written, it's a 1. So I'm subtracting that 1 as I move it over. So then, and again, do I need the 1? Not really. Does the negative have to stay in the denominator? Not really. I can kind of put it out to the front. So I have negative 4, p to the 6th, m squared. Okay, now here, what do we know? Anything to the 0 power is 1. So this just becomes 4 times 1, which is just 4. Okay, now the way that I usually do this, you can do this 2 different ways. I tend to just distribute the exponent first and then take it to wherever like if it's negative, then I move it to the other side. Okay, so then I have 2 to the negative 4 and x to the 2 times negative 4. So that gives me 2 to the negative 4 over x to the negative 8. So since both of these have a negative in them, that means I need to move them to the denominator. So I've got 1 over 2 to the 4th, x to the 8th. And then the last thing I'm going to do to simplify is I'm going to actually take 2 to the 4th. So what is 2 to the 4th? Well, it's 2 times 2 is 4, times 2 is 8, times 2 is 16. So my final simplified answer would be 1 over 16 x to the 8th. Okay, so now we have powers and we have multiplication. So remember, you want to kind of treat this sort of like order of operations, right? So we typically do exponents first. So we need to take these exponents that are on the outside of the first and the third parenthesis, and we need to get them inside. And then once we have that simplified, then we can multiply across. Okay, so remember, if there's more than one thing in the parenthesis, both things get it. So I have negative 2 to the third, a to the, and it was a 1 there, right? So I'm going to have a to the 1 times 3 is to the third. And then I'm just multiplying it by negative 3a squared. That's not changing at all. And then I have this 4a to the third squared. So I'm going to have 4 squared, and then a, and then when I have a power to a power, remember I multiply. So I can simplify. I have negative 8, a to the third, times negative 3, a squared, times 4 squared is 16, a to the 3 times 2 is 6. So now I'm going to take my coefficients. So I have negative 8 times negative 3 times 16. And then they all have the same base, so now I'm just going to add my exponents. So I have 3 plus 2 plus 6. So my final answer, negative and a negative will be positive. All my coefficients multiplied together gives me 384. A to the 3 plus 2 is 5, plus 6 is 11. Okie dokie. Now again, we have something, 2 things in a parenthesis, raised to a power. So even though they're on the denominator, it's fractions, right? A numerator and denominator, they're both going to still get that negative 2. So I have x to the negative 2 and y to the negative 2. And so remember what I said, that if it's got a negative exponent, we say it's on the wrong side of the fraction bar. Since these are different different variables, there's no way I can combine them. So all I need to do is just flip them over to the other side. So I'm going to find the reciprocal of this, and I get y squared over x squared, and there's nothing else I can do to simplify that because I have 2 different variables. Okay, So now we are going to look at our next one, more division. So my 3 doesn't have anything to simplify with. So now I'm going to just start looking at my variables and asking myself, okay, where do they go? Well, so I'm going to bring this 3 down. And now, if I have an x to the third and an x to the -4, well, which one of those has a larger exponent? Well, 3, even though that 4 seems bigger, it's negative, right? And we can't have a negative exponent, so we need to bring them up to the top. So that's going to be my x to the 3 that's there. And then remember, when things move on the other side of the fraction bar, they change signs. So if it's a -4 on the bottom, it's going to become a +4 on the top. So I took care of my x's. And then I look and I say, okay, where's the exponent larger for the y's? Well, 0 is bigger than 1, so that means my y is going to go to the denominator. I'm going to take the 0 that was there, and if it's negative on the top, when it comes to the denominator, it's going to become positive. And then same thing, z to the 0 in the denominator, that's going to be bigger than a -1. So I have the 0 that's there, but when I move that down, that -1 down to the denominator, it's going to be a +1. So I can simplify. I have 3x to the 7th over yz. And I can put a 1, I can have an exponent of 1, but I don't really need to. Okay, a few more examples. So again, we're going to look at our 2 and our 8. 2 and 8, they can reduce with each other. So they both can reduce by 2. So I'd have 1 over 4. So I'm going to go bring that over here, 1 over 4. Okay, and I think about, okay, where is the x larger? Well, there's x to the 4th on top, so, and an x squared on the bottom, so it's larger exponent on the top. So I'm going to have an x to the 4th, and then I'm going to subtract, because when those 2's come to the other side, they change sign. So it's going to be a -2. And then again, I look and I say, okay, where's my y exponent larger? Even though 0 is not big, we know it's bigger than -3. So the y is going to be up in the numerator, and I have a 0. And when I move that -3, it's going to become a +3. So I have x squared y to the 3rd over 4. Okay, now what you can see is that I have a fraction and a fraction, and nothing in this fraction reduces, and nothing in this fraction reduces. So I'm going to go ahead and simplify the numerator and simplify the denominator, and then see what I can reduce. So I have 3 times 3, that's 9. And then I have an x squared and a y, so those aren't like terms, so I'm going to just put them together, x squared y. And then I have a 1 times a 6, so that's a 6. And remember, if there's not a coefficient, we know it's 1. And then I usually put them in alphabetical order, so I'm going to go ahead and put my x in the front and my y squared second. Okay, so we look at our 9 and our 6. We think, does that reduce? It does. They both are able to reduce by 3, so that would be 3 in the numerator and 2 in the denominator. So I have 3 over 2. And then I look at my variables. Where do they go? Well, x has a larger a larger exponent in the numerator. So I'm going to keep it up there. That'll be squared, and then I'm going to subtract the one that's coming up. And then my y's have a larger exponent in the denominator, so I'm going to leave the y's in the denominator. I have 2 there now, and when I bring this one down, it's going to subtract 1. So I just simplify to 3x over 2y. Okay, now last example. Now this one looks a little tricky, but guys, we just follow the rules, right? If it's the same base and we're multiplying, then we just add the exponents. So I have x to the m plus 1 plus m minus 1 plus, and then if there's no exponent written, remember it's a +1. And now I just combine my like terms. So I have m and m, so that's going to be x to the 2m. I have a -1 and a +1. Those cancel each other out, but then I still have a +1. So that's my simplified expression. Okay, hopefully this made sense and that you will have no trouble. I would say the homework is a little bit easier than some of these examples. Thanks for watching.